plating requires that whenever we have a blind via or epoxy-filled hole, that the first copper in the hole goes in the hole and wraps onto the top surface of the circuit board. And what happened was originally when people were doing blind vias or epoxy filled, there was no requirement. So we would just plate the entire barrel with copper, and then we'd get a dot of plating higher than the surface, which would get in the way of imaging. And we'd planarize it back to a smooth surface, and then we would plate on top of it, creating a butt joint. Literally, the barrel was not part of the copper that would plate over it. And during assembly, with the expansion of the material, it would cause a separation. As people would heat up the board during operation or during assembly, there would be separation or intermittent opens. So that's wrap plating would wrap copper onto the surface. So the starting copper here and the final plating over here would lock in this plating in the barrel and keep it safe as it expanded and contracted during assembly. So why would people want to epoxy fill or do blind vias?
Yeah.
So most of it is as we got into higher density, we are able to have a surface mount land and put the via inside of the surface mount land and save real estate rather than having a surface mount land, a trace, and then a via that went down from there. So it saved real estate. Second reason for doing this was as the speeds of high-speed digital and RF signals got higher and faster, the delay time between coming up a via from a bypass capacitor from the capacitor to the trace to the via to stabilize the voltage in a component, it was too long. You're 750 megabits. You're starting to run into problems of the delay time. You needed more immediate. So folks, to solve this problem, would put the via in a BGA component, and then on the bottom side of the board, the lands for the bypass capacitors would go directly across power and ground, and the via would be right in the lands on the bottom side of the board to give it the fastest response time.
I see.
That was one reason. The other one was in blind and buried vias. Whether you put in a component or not, you're going to have wrap plating because we image the inside. Let's say this is a top layer and this is a blind via inside. We're going to do the pattern on the inside, but the top layer has to be a sheet of copper, a continuous sheet of copper during the sublamination. And that is going to be a button plate, which is planarized, epoxy filled and planarized. And so that's when the wrap plating needs to be there so that the final copper protects it from the expansion contraction of the barrel.